Okay, welcome to the second video of 2.2 bonding between atoms. In this video, I would like to cover the metallic bonding. So jumping to slide 8. Just like in the last video, if you know any of the properties, you don't have to write. If you find some information is new, then make sure you write it down under metallic bonding, please. Okay, now what will be covered is that metallic bonding is the force of attraction between metal cations and their delocalized valence electrons. Now, if you don't know any if you don't know the meaning of any words in here, you should make sure that you know them first. Then we'll look at the physical properties of metallic elements. They can be explained using the model for metallic bonding. So you need to be able to draw the model as well. Explain the melting and boiling points and electrical conductivities of metallic elements by using the model. All right, so that's what you need to be able to do. Okay, slide 10. Metallic bonds. Let's look at what it is. The definition has already been mentioned in the table just then, little table. But how do metallic bonds occur and why do they stay together? Firstly, the electrons are equally attracted to each cation. Now, what cation are we talking about? It's pretty much nucleus with inner shell electrons, not the outermost shell electrons. Because those outer shell electrons are delocalized. They are free to move around. They're called the free electrons for that reason. Because those free electrons are there, they can act as glue for all the positively charged cations within metal. This metal can be of its own element or a mixture. In that case, you would call that as an alloy. We'll watch this video later. Free electrons. Because there are so many of them, it would make something like a sea of electrons. And the sea of electron is a term that is described how it looks like. You can see that in this first diagram here. You might have to zoom in a bit later, but this shows the sea of electron. So imagine that there are so many electrons that you can even, picture. But that's holding all the cations together. In terms of drawing, you might need to be able to draw something like this. And there's a bigger image of that on the next slide. Here you go. So, metallic bonding has got certain properties. Metallic elements are usually hard, usually malleable and ductile. They have high melting points, Tm, and also boiling point, Tb. And also they are conductive, very good in thermally as well as electrically. Now, when I say hard or malleable ductile, that also depends on what element you're looking at. Group 1 metals tend to be fairly soft, like sodium or potassium you can usually cut with a knife. So fairly soft. It's like butter almost. Whereas most of the metals would be solid, except for mercury. Or if you look at the melting point, you know that most of them stay as solid at room temperature. But things like gallium, you know that a gallium would melt at 35 degrees or something. It's fairly low, or 25. I forgot. Anyway. Conductivity. Now, this can be explained if you are able to draw this diagram on the right. Or above just me. Yeah. So cations, just draw lots of circles next to each other with positive drawn in it, and just draw the electrons around it. You can add arrows. That shows, whenever they want to, they can be moving around. By using that, you can explain the melting and boiling points and electrical conductivities of metallic elements. Yeah. So melting and boiling point wise. Now, what particles do you see? What do you see in taking part of forming this bond? It's positive and negative. Now, if they are static, I'm going to use this word again in ionic bonding, but if you have got particles which are statically positive and negative, i.e. The charge will stay, they would have very high attraction. So metals would have, you would require a lot of energy to break this bond between electrons and cations that's forming this bond. Okay. Conductivities wise, because electrons are freely able to move around, if you push electron from one side by supplying more electrons into it with power source like batteries or a power pack, all the electrons will drift along because they repel each other, so you would see electron flow. So by using this diagram, you can explain those properties. All right, moving on. Okay, so property depends on how strongly or weakly cations are held by the electrons and how cations are arranged. What it's saying is that these properties can be altered if you add heat or remove heat energy from the bonding itself. Then you can rearrange the metals a bit. So if you say pack more nicely, you would be able to increase the hardness, toughness, durability of metal, just like what you would do if you're a blacksmith, I suppose. Heat up or put the sword into cold water to chill down very quickly, so that you can rearrange atoms as you want. That's what they did, and we might do the prac again on that one. Okay, so here are the points that I want you to be able to answer. So they are the questions. Okay, so for metallic bonding, what were the substances metallic bonding when we were looking at the prac? I think there were two substances which only had metallic atoms. Second question, what were the observations? What did you see as common things? And last question, how do you explain these observations? Now you can do this. You can do how to explain question with the diagram, and hopefully you can do now. So even if you didn't take much of the notes from the previous lecture notes here, I want you to try doing these questions. All right, same goes for these properties. Conduct electricity. Why do they conduct electricity? Malleability. Why can you shape into a sheet and don't break? Look at the structure again. Finally, have high melting points and boiling points, which I have already explained to some extent. So if you can write that in few sentences, that would be good. Next video is gonna be on about ionic bonding, so stay tuned. And this is the end of the second video. All right, see ya.